Welcome to KP classes. I'm Ruku Raju, Geology faculty over here. So today in this video, we'll be discussing about geomorphology. So we know geomorphology is a very important subject for all competitive exams related to geology. It's very important for NET examination, for GSI paper, for GATE, in IIT JAM. Every year, minimum 3-4 questions come from this particular subject. So these are the syllabuses that we have, portions that we have to cover in geomorphology section over here. So we have to study the processes associated with the geomorphology, weathering, mass movement, erosion, transportation, deposition, the cause of geomorphology, like the causes of formation of the sediments or the variations that happen on the landform, surface processes. We have to study in detail. Then the geomorphic processes and the landforms associated with each of the geomorphic processes. Fluvial activities, the deposition, transportation and erosion of fluvial system, and the landforms associated to that. In the same way how erosion transportation happens in a aeolian system and the landforms associated to each of the process. Same way glacial, coastal and karst topographies are also very important. We'll cover all those topics over here. Then river forms and processes, stream flow, stage, discharge relationship. This section is very important for NET examination and GSI questions. They ask a lot of questions about the different river forms and the relationship between each of the variation stage, discharge processes are very important. Then we have to study about the landforms that are associated with climate, rock type, structure and tectonic portions. So these are actually, we can include them in fluvial landforms or in aeolian, we can include them or we can study them separately. Then the last portion is hydrographs and flood frequency analysis. So in GATE, they can ask numerical questions. In GSI also, they ask numerical questions about the stream hydraulics portion, bifurcation ratio related questions. These are very common in GATE paper and in GSI also. Conceptual questions do come from geomorphology. Very lengthy conceptual questions come. So every year in GATE, minimum 2 questions they ask from geomorphology section. In NET also they ask for minimum for 3 to 4 mark questions will be coming from geomorphology. And in IIT JAM also geomorphology is very important topic. So this particular subject is both conceptual questions and numerical questions can be asked. 2 mark questions are very common in NET paper. 2 mark questions usually come from geomorphology section also. So let's see, today in geomorphology section we'll be studying about the river channels. So when it comes to river channels, these are the major landforms associated with the fluvial system. So there are mainly 3 major types of river channels: alluvial channel, bedrock channel and semi-controlled channels. These are the 3 major channels: alluvial channels, bedrock channels and semi-controlled channels. Bedrock channels means the river channels that cut into bedrocks or cut into rocks, that are called as bedrock channels. Same way alluvial channel means the channels those cut into sediments or the alluvial sediments, those are called as alluvial channel. So the alluvial channel bed, the banks, everything will be composed of sediments. Semi-controlled channel means it is an intermediate portion, like locally in some places the channel may be of bedrock channel. In some places it will be cutting into an alluvial deposit. So it is different in different sections. So locally controlled channel is semi-controlled channel. So alluvial channel means the channels that are cut into sediments, both beds and the banks will be having sediments. In bedrock channel means the channels those cut into the rocks. So the most important type of channel is alluvial channel. So let's see in details what are the different types of alluvial channels. So over here you can see we can divide the alluvial channels into 4: braided channel, straight channel, meandering channel and anastomosing channel. So we can there are different way of classification of alluvial channel. This is one way of classification. This is based on their sinicity. Based on the sinicity is one factor. Sinicity means Simply the irregularity of the channel, like the channel course irregularity is defined by sinuosity. We can depict or we can notate the sinuosity value as ratio of channel length measured along the center of the channel to that of the valley length measured along the valley of the channel. So this gives the sinuosity of the channel. Based on sinuosity, we can divide alluvial channel into straight and meandering, braided, anastomosing, and they each of not only sinuosity, their landforms associated with each of these channels are also very different. Braided channel means a particular channel system that has huge deposits are present inside the channel. Along the course of the river flow, there is huge deposits present inside the channel. Those are called as braided channel. Anastomosing channel means these are different channels are there. All these channels sometimes they will join together. They maybe be bifurcate again into different channels in the downstream direction. So in a like in a if we watch anastomosing channel from a satellite or remote sensing purpose, like from a large distance, we may feel them as a braided channel. It looks like a braided channel, but they are entirely different. Then straight channel means very normal. The channel has the sinusity condition is very low, like almost equal to 1. There is no curvature. Those are called as straight channel. And then comes the meandering channel. So meandering channel means from the word itself, they will have meanders will be there. So the channel happens in movement of flow happens in this particular way. A very sinusity value is greater than 1.5. Those are called as meandering channel. Sinusity value is equal to 1. Those are called as straight channels. So we are not going into detail about each of these sections. Today in this class, we'll be studying about meandering channel. So I'm not explaining what are braided, anastomosing and straight channel. That we'll do later in a different section. So before going into meandering channel in detail, this is another type of classification. Alluvial channels we can classify them into three: suspended load, bed load and mixed load channels. This is on the basis of type of sediments transported in the channel. Whether the amount of sediments that are transported or the what type of particles are transported or in what way they are transported. So we know that transportation of sediments in fluvial system, they can happen as a bed load. That means the sediment transportation happen at the bottom of the channel. Thus are called as bed load. Along the bed, transportation happen. Suspended load means finer particles like clay, silt, sediments. They will not be settling down. They will stay in the liquid and they will be transported as suspended load. So bed load means sediments, coarser sediments which are transported along the bed. So the transportation can be by traction, saltation. These are the processes that happen. Then suspended load, those are the particles which are finer, and these fine particles will be transported in the river system. Okay, in the water. Those are called as suspended load. Now, depending upon what type of sediment or depending upon the percentage of from in the total sediment, how much percentage of the sediments are of bed load. Depending upon that, we can divide the alluvial channels into suspended load, bed load and mixed load channel. Suspended load channel, so from the word itself it's very clear. Suspended load channel means there's a quantity about 3% of the channel, sorry, less than 3% of the total sediments are of bed load. So there is only less than 3% of the channel sediments that are carried by the channel are bed load. Rest of them are suspended load. That's why that particular channel is called as suspended load channel. Then when it comes to bed load channel, greater than 11% of the sediments that are transported are of bed load. So on the of the total sediments transported, greater than 11% of sediments are of bed load, then transported as bed load. Then we call the channel as bed load channel. In between these two conditions, an intermediate stage is the mixed load channels. Mixed loads have the total sediments transported has bed load is in between 3 and 11 value. Then we call it as a mixed load channel. Now in a suspended load channel, the width to depth ratio. Width to depth ratio means, so if let me, yeah, so you can see this picture over here for the reference of width to depth. So this is the width of the channel. So imagine the river course goes in this particular way it goes. Okay, this is the cross sectional view. So this is the width of the channel and this is the depth of the channel. So if I take a ratio, width to depth ratio, that is defined, that is what is defined over there. Yeah. So over here, if we see, for a suspended load channel, width to depth ratio will be always less than 10. For a bed load channel, width to depth ratio will be greater than 40. That means which one is larger? In a bed load channel will have much higher width than the suspended load channel. Suspended load channels are not wider, they're shorter. Their length, their width is very less comparing to their depth. Whereas in bed load channel, they have wider, very wide comparing to their depth. So bed load channel has a width to depth ratio greater than 40, and for suspended load channel, width to depth ratio will be less than 10. For a mixed load channel, it will be in between 10 and 40. We get with the suspended load channels are usually present at a terrain that has a gentle gradient. That means the very less steep, almost horizontal, or a less steeper terrain has suspended load channels, whereas bed load channels usually form at a steep terrain where the gradient of the terrain is steeper. There bed load channels can form. Suspended load channels usually form at a gentler terrain. Mixed load will be forming at an intermediate or a moderate gradient situation. And then when it comes to sinuosity, suspended load channels are usually sinus, or they are much more curving. Their sinuosity value is greater than 2. Whereas for a bed load channel, their sinuosity value is less than 1.3. Okay, so bed load channels are comparatively straighter than suspended load channel. Bed load channels usually form at much more steeper terrain. Suspended load channels usually form at like gently grip dipping or gentle gradient terrain. Width to depth ratio is much lesser in suspended load channel. Width to depth ratio is much higher in bed load channel. So next, why I described this, because when I go further, when we define the meandering channel, you should know what is a suspended load channel means. Now let's see the meandering channels in detail. So what is a meandering channel? Meandering channel has a sinuosity of greater than 1.5 value. That's the first point that you have to keep in mind. Its sinuosity is greater than 1.5. What is sinuosity? Sinuosity defines the irregularity of the channel course. How can we measure the irregularity of the channel course? We'll measure the length along the channel. We'll measure the channel length along the center of the channel. So for example, you can see a river course over here. Now from here to here, these 2 points, if I measure the along the center of the channel, this is the distance. Okay, through the center of the channel, this is the distance between 2 points A and B. If you cannot see, yeah, this color, white color will be much more brighter. So this is the distance between A and B through this along the center of the channel. Now if I take the length along the valley, so this is the distance between 2 points. If I move along the valley, this will be the distance between 2 points, or we can say that is the displacement between the 2 points. This one. Okay, so the first distance is can be notated as small letter AB, and the displacement is P and Q. So the distance between distance along the center of the channel, or that is the channel length, to that of the length of the channel along the valley, or the displacement between 2 points, gives the sinuosity ratio. So though the curvature is much higher, sinuosity value, so sinuosity is small letter AB divided by PQ. This is sinicity. So you can see from here the displacement is much smaller than the channel course length, right? The distance through the center of the channel. So this will provide that the sinicity is very large or very high, greater than 1 or greater than 1.5 for this particular channel, and this particular channel is a meandering channel. Okay, now next about the meandering channel. So when it comes to the flow pattern of a meandering channel, it has a helical flow. So if I'll show you this picture, this is much more technical pictorial representation of the entire fluid hydrodynamics of the meandering channel. So meandering channel, as I said, it has the sinicity value is much higher. So that's the first thing that you have to keep in mind. Sinicity is greater than 1.5. Next thing is it has a helical flow. Helical flow, that's a second term, second criteria of meandering channel. It's helical flow. So that you, let's see over here in the image, this is the downstream direction. Downstream direction is this, flow happens towards this direction. So the water flow happens from here. This is how the water movement happens. It is a helical flow. A zigzag movement is what happens in the channel. It is not like the water is not flowing from here to here in this way, or it is not flowing through the center, nothing. It is moving in a helical pattern. A zigzag pattern is what is happening in the meandering channel. And why this is having a helical pattern? This is simply because of the centrifugal force that is happening to the river channel. So we know what is a centrifugal force. So whenever an object takes a curvature, so you can imagine this as a circle. So if an object is passing through the circle, it always has a pressure force that is pulling away from the center of the circle, that is the centrifugal force. So in this way the water will be pulled out of the into the outer end or into the outer bank. That's why when after passing this side, again when it comes over here, this is the, in this way we can say this is the circle, and the water will be moving towards this direction. Okay, so that's why this centrifugal force that is present over here, or the centrifugal force that is applied to the water, is what causes the helical movement of water. Now the next point that you have to remember is that the meandering channels sinicity value is greater than 1.5, and they are actually a suspended load channel. They are a suspended load channel. That means their width to depth ratio is much lower. It is less than, so we saw over here the when it is a suspended load channel, width to depth ratio will be less than 10, and the slope of the terrain will be gentler situation. In the same way, the meandering channels are a suspended load channel, hence the width to depth ratio will be much smaller, and they are found at a lower gentler terrain, where the gradient of the terrain is much lower. Okay, so we get braided channel at a steeper terrain, the width to depth ratio is much higher because braided channels are bed load channels. Meandering channels are suspended load channel. So suspended load channel means the sediments present in the sediments which are transported by the meandering channels are finer in size. They are much finer. They are usually transported as a suspended load than the bed load. Hence the sediments that are hence the river pattern or the channel system is a suspended load channel. Its width to depth ratio is much lower, and they are found at a lower gradient terrain. Now the next thing is the you can see this coarser darker line over here. This line, these are actually the how the helical flow that happens, and this line we can call it as talweg, a talweg. So what is a talweg? A talweg is actually talweg is actually the trace of deepest points along the channel is what is called as a talweg. Trace of deepest points along the channel. So if the deepest portions in the channel will be always along the talweg line. So over here, these are the deepest points. Wherever the flow velocity is higher, that there will be the stream channel will be deepest over there. So wherever there is talweg, there the depth will be also higher, velocity will also be higher. So though the flow is helical, talweg will also be helical in the meandering channel. Okay, so meandering channel, talweg will also have a helical shape because the flow happens in the meandering channel is also helical shape. Now, when it comes to the water flow pattern in detail, when it comes to the water flow pattern in detail, the water surface, though the water is pulled towards this side over here. So this is the outer surface, or that is the concave bank. We can call this as the concave bank. Whereas this is the convex bank. Okay, this is the convex bank and this is the concave bank. As I said, the water is pulled towards the concave bank because of the centrifugal force. Hence, because of that, the flow velocity will be very higher. Higher flow velocity will be there in the concave bank, and this causes more erosion and more erosion and downcutting along the concave bank. So concave bank will have more erosion and downcutting, and if concave bank has more erosion and downcutting, more deepest portion will also be the concave bank. Okay, so concave banks will have the more erosion and undercutting over there. So because water centrifugal force, the water will be pulled over here. This also will cause water surface will be elevated in the concave bank. Water surface, water level will be always higher in the concave bank than the convex bank. Now, so the water, because of the water force, higher force over here, this concave bank will be eroded and undercutting will be higher. And exact opposite thing, in the convex bank, velocity is comparatively lower. Hence, in the convex bank, the velocity of the flow is lower. That causes deposition of sediments happening in the inner bank or in the convex bank. Okay, so outer bank will have erosion process, inner bank will be having, so inner bank will have deposition and outer bank will be having erosion. Okay, so outer bank and inner bank, both outer bank is of concave shape, inner bank is of convex shape. The water surface will be elevated along the outer bank. Because of that, erosion and undercutting of the banks will be higher here in the concave bank, whereas in the convex bank the water velocity is much lower. That causes the deposition of the sediment. Now after from this concave bank, water currents at this over here will be directed to the next concave bank in the other side. Okay, the water will be directed towards the next concave bank. Here again at this concave bank, all along the concave bank, erosion will be more. In the convex side, deposition will be happening. Now, this deposition that takes place in the convex bank is what causes formation of point bars. Point bars. So, next terminology that you have to study is point bars. So point bars are the terminology that we give for the deposition that happens in the meandering channel. Uh, in braided channel, the depositions are simply called as bars or channel bars. Whereas here we call it as a point bar. Point bars are usually channel boundary deposits. We get them in the channel margin because this deposition happens along the convex margin. So those are the point bars that are present or depositing and the convex margin. So the next point is because of the steep channel gradient, if it is a graded channel or a straight channel, usually what happens is they present at a steep gradient terrain. So in the steep gradient terrain, the downstream momentum of the flow is much higher. So though the downstream moment is much higher, that will prevent this significant cross channel movement of water. The momentum is downstream flow momentum is much higher in the steeply dipping terrain or steep gradient terrain, which having the braided channels or straight channels. So that will, because of this higher downstream momentum, that will prevent the significant cross channel flow, and this will cause formation of alternating bars over there. So that's why in braided channel or straight channel there are bars present inside the channel situation, whereas here in the meandering channel, the bars or sediment deposition happens along the channel margin, because there is cross channel flow happens from this margin to the next margin. The flow happens in a helical flow is happening from one margin to other. A helical flow takes place. So there is this inter-channel flow, inter-margin flow that happens over here. Okay, then the next thing is, let's the cross section. So over here in this picture, before going to the landforms associated to the meandering channel, in this picture you can see that they have drawn the different over here bound A B situation. So this is the, if I notate it as this side is A, so that A and B, you can see that the depth will be much higher at the A side, and towards the B side the depth is decreasing. This is because this side, this is the concave side where is undercutting and erosion is higher, whereas in the B side, that is the convex side, where the inner side where the deposition takes place. Okay, now so in this picture over here, it is explained very well. Okay, so look at this picture. So the inner bank region is over here. This is the outer bank region. So the flow happens, this flow mentioned over here, this is because this is the centrifugal pull that is mentioned over here. The water will be pulled towards this side because of the centrifugal pull or the centrifugal force over here. The water level will be higher in this outer bank region. Super elevated water surface is present in the outer bank region, whereas in the inner bank region the water level will be downwards, and this is where the point bar deposition happens. So there is the flow of water will be, this is how the flow happens. Here at this side the flow energy will be much higher. Here this side the deposition will happen along the margin. The point bar deposition happen. Okay, now though the point bar deposition happens along the margin, along the inner margin, so with further deposition of the sediment, so this is, imagine one set of deposition happened over here. This is how the one set of point bar deposited over here, then that will cause, and again this side underwent some migration, erosion happened. So the river channel will be shifting from this point to this side. The river channel shifted. Then again after some time, the next set of deposition happened over here, and another set of erosion happened over here. So this is the channel now. Again the channel got migrated towards this side. So in this way, with further erosion and further deposition happening, point bar formation happening in the inner bank, and the erosion that happens in the outer bank causes migration of the channel, and the migration of the channel will be always in the direction of dip of the point bars. So you can see these are all point bars, previous point bars that are present. So all these point bars are dipping towards the direction of channel migration. Channel migration is happening from this direction. This is the direction of channel migration, the which is defined by the dipping direction of the point bar. And you can see that point bars, it looks like a cross bedding, right? So it is it looks like it has a shape of, or the point bars and the lateral, this process is called as lateral accretion. This is a very important terminology when it comes to point bars. So in point bars, lateral accretion of the sediments happen. From this side to this side, the sediment is more and more deposition happens. Always deposition takes place where in the inner bank, and in the outer bank it will be eroded. The channel will be migrating towards this direction, whichever direction the point bar is dipping, that direction the channel will be migrating. So this deposition of the point bars, like one after the other, laterally deposition happens to the point bar, or the growth of point bars is lateral growth, and that lateral growth of point bar, or this lateral type of deposition of sediment, is called as lateral accretion. So lateral accretion is the terminology that we use to define the growth of point bars. So there is vertical accretion also, lateral accretion also. In vertical accretion, the deposition happen on top of each layer, so the growth happens vertically. In lateral accretion, growth happens laterally. Okay, vertical aggradation is we can also call it as aggradation. So point bars formed by lateral aggradation. Lateral aggradation is the cause of formation of point bars, where laterally the deposition of sediments happen laterally, one after the other. Point bar deposit laterally in this particular way. In whichever direction the point bars dip, that direction is the direction of migration of channel. Now, as I said, they look like this stacking of point bars. It looks like it is a cross lamination or cross bedding. That's why we call this stacking of point bars as epsilon cross lamination. Epsilon cross lamination. This stacking of point bars are called as epsilon cross lamination. Epsilon cross lamination. Okay, or epsilon cross bedding, or epsilon cross stratification, depending upon the size of the point bars. Okay, now the lateral accretion or lateral stacking of point bars is why we call it as a epsilon cross lamination or epsilon cross bedding. So this lateral stacking of point bars is because of the lateral accretion that happens. In whichever direction the deposition takes place, that defines the direction of migration. Or I can say that this, in whichever direction the point bar is dipping, that direction, so this is the direction, this is the direction of point bar dipping, and the channel movement, channel flow direction is in this way, right, towards the camera, towards this direction the channel bar is, towards this direction is channel is moving. So the direction in which the river is flowing, that is towards you, towards the screen. From the screen the channel is moving, or the channel is flowing, and the paleocurrent direction, whenever we get a point bar, paleocurrent direction can be defined in such a way that paleocurrent direction will be perpendicular to the direction of dip of the point bars. The point bars dip in this direction and the flow happens in this direction. Hence, the flow takes place perpendicular to the direction of point bar deposition. For example, this is the flow happens in this direction. Point bars will be stacking over here, and this will be dipping in this direction. Migration will be happening in this direction. So I can say that the migration, channel migration, direction of channel migration is perpendicular to the direction of channel flow. In meandering channel, in whichever direction the channel migrate, that is roughly perpendicular to the direction of channel flow. In whichever direction the point bars are stacking, or in whichever directions the point bars are dipping, towards that direction the channel will be migrating. Perpendicular to that direction, the channel flow will be. Okay, so these are the details about the point bars. Next, let's see more detail, other structures that are associated with the river meandering river system, the other depositional landforms associated with the river meandering river channel. Excuse me. Okay, so then the major depositional landforms associated with meandering channel are natural levee, flood, crevasse play deposit, then point bars, then comes the deposits that are happen in the swamps, back swamps, Oxbow Lake. There are more. There is chute, bar formation, etc., etc. There are more terminologies are there. Okay, so first let's see what is Oxbow Lake. So as I said, the channel migration, the river channel is in this way. So imagine over here, this here the migration will be happening towards this direction. Yeah, migration will happen in this direction. Here the migration will be happening towards this direction. Now imagine a situation where this is the river channel system. Now as I'll draw much smaller version so that, yeah. So here we know that in the concave side it is erosion happens. In convex side over here it is deposition. So the migration happens towards this direction. So imagine with further migration that is happening, this entire channel will be the one that forming in this way. Imagine a channel situation like this. So here also there is erosion happens. Here also this is also a convex side. Erosion happens. So further erosion that causes the these two stream channels can join in that and makes the flow happening in this particular way, right? Which will abandon the channel over here. So this particular type of cutting off of meandering channel is called as neck cutoff. Simply because of the morphology, because of the channel migration and erosion that happens, the two sides of the meandering channel. So initially the meandering channel was in this, the channel was in this way. With further erosion that happens in these two sides can cause joining up of the channels, and always the channel will choose the displacement, right? The for the movement, like it is easier for to take the less course to travel. So the channel will now start moving in this direction, that will cause abandoning of this section over here, will be abandoned, and this particular section will be forming Oxbow Lake, where there will be water initially. Later on maybe fine sediment deposition happen, floodplain deposition, channel fill will be forming. Channel fill deposition can happen in the Oxbow Lake, or it will be preserved as a lake itself later on if there is perennial water supply. So simply this particular cutoff of channel is called as neck cutoff. There is one more type of cutoff. So imagine this is the channel situation. a meandering channel in this particular way, and suddenly flooding happened. So the water flow was, this is the water flow was happening in this particular direction. Suddenly flooding happened, and because of the flooding, or we know during flooding the water will be overflowing all around the floodplain. So during this flooding, the channel found a new course. It founded this course over here. So it attained a new course in this particular way. So now the channel will flow from here to here. This particular cutoff of channel is called as chute cutoff. Chute cutoff. So chute cutoffs can form during the flood water flow, like overflow situations is what causes chute cutoff. Neck cutoff is because of the further erosion or the concave side erosion and migration of the channel can cause two channels can combine together in a single river, that can cause the curved portion to leave away. Here chute cutoff can also causes formation of oxbow lake. Sorry, oxbow lake can be formed. Okay, now there are, other than these oxbow lake, the next top terminology is levee. Natural levees are actually formed in the floodplain along the channel margin. Those are formed by vertical aggradation. Vertical aggradation or vertical stacking is how the natural levees are forming. Crevasse plays are formed by during the flood situation, when the overflow condition happen. Levees can form cracks, and that those are the crevasses, and through the crevasses the water will escape into the floodplain, and deposition can happen in the floodplain. Those are called as the crevasse play deposit. Here these are the crevasse play deposition that happen. Then in the beyond the levees, further during the floodplain, further deposition happen in the most lower gradient terrain, or the mean sea level lowest level terrain. All the organic matter, everything will be deposited. Those are called as back swamps. Then yeah, these are the major terminologies that are associated with meandering channel. We'll see the entire deposition landforms, about the grain size, like all around, whether they will have a coarsening upward sequence or whether they will have a normal gradation. These things we'll see in detail about the landforms associated with the meandering. So I hope you understood about the basics, the hydraulics portion, dynamics of meandering, formation of point bars, and the landforms associated to the meandering channel. So thank you so much.